Hi, this video is going to focus mainly on the display that I've integrated into the speed control program that you can see in some of the earlier videos. I wanted the Pi to run this speed control in a standalone mode. In the original code, it needed another computer to start and stop the program and to boot the Pi up and shut it down. As we watch here, the Pi's been powered up and booting up on its own. The program's now up and running, as denoted by the second line, and now I've energized the motor, and it picks up seeing both the target RPM and the actual RPM. Here's another mode showing just the error between the target and what's actually being recorded. Now we move to a duty cycle mode where we're showing how much power. This is not a percentage, rate of a measure of the PWM signal. This is a bar graph view of the PWM signal. Now we're moved into the display color mode, and I'm cycling through the colors here. As you can see, the up and down buttons control the color being selected, while the left and right buttons on the display control which mode the display is operating in. Off camera, the power has been cut to the motor. The speed controller code senses this and sets the display to read ready. And finally, pressing the select button on the display board stops execution of the program. That covers the key features of the display and how the 5 buttons have been set up to control the output of the display and the code. Just like the original program, speed control program, this program is written in C and uses the WiringPi library. By the way, the WiringPi library has recently been upgraded to include function calls that are designed specifically to address this type of display. And also included when you upgrade the your WiringPi library is a demo piece of code that shows you exactly how to use those functions, and it's well worth the time to take a look at that. And now what's being demonstrated here is that when the motor is turned off and you're in the ready mode, you can adjust the background color or set the motor speed that you want the motor to operate at when it's powered up. Sorry about that. So here we are back with the motor speed control back in the ready mode. We powered the motor up and we have it in the speed arrow mode. We're advancing the speed. It advances in 200 RPM increments. So it'll go from 5,000, 5.2, 5.4, 5.6 and so on, or down negative would be 5.48, 4.6. You get the idea. And what I'm trying to show here is how quickly the speed comes back on, or what kind of error you get as you move. Given the 400-watt spindle motor and 48-volt supply and the electronic controller that I'm using, 1400 RPM is about as low as I can get the spindle motor to run reliably. It wanders some, as you see here, at that low RPM, but if you put a load on it, it settles down and will again turn it at a good steady rate. Back to the bar graph throttle signal, or PWM signal, and off camera what I'm doing is applying some load to the spindle while holding the target RPM at 4800. Of course, you're seeing the throttle respond to it to maintain that constant 4800 RPM. Now we'll increment the target RPM up to its maximum of 10,000 and watch how the throttle signal responds as we advance it. You'll see it's not very linear over the range. That's a product of the motor and again the electronic controller. Well, I guess that pretty well covers how the display's been set up. If I missed anything that leaves you curious, please don't hesitate to ask, and I appreciate you watching. Thanks a lot.